Each auto brand is unique. When people hear Toyota, they often think of high quality. The company's identity as a Japanese brand is only part of the reason. Over the past decades, it has gained a reputation for stellar standards of manufacturing and after-sales service. Irrespective of this, it's still no secret that the heart of any car is the engine, because without it, the car is going nowhere. Toyota understands this concept and incorporates it into its long-standing work ethic by continually improving its car engines and manufacturing reliable, quality cars. The latest engine by the Japanese company blows everything out of the water. What exactly is Toyota's new engine, and how powerful is it? Stay tuned to find out. Did you know that 80% of Toyota vehicles sold 20 years ago are still on the road? Reliability means the consistent quality of a product. The official Toyota engine specifications highlight some of the biggest selling points. These vehicles are durable and trustworthy. While past conversations about Toyota tend to be focused on reliability, ease of repair, and less expensive parts that are easily available, it's time to take a closer look at how Toyota's engines have evolved and learn a little about what else makes Toyota a leading automaker. The new Dynamic Force Engine. Toyota's new Dynamic Force Engine adopts high-speed combustion technologies and a variable control system. It also achieves greater thermal efficiency, resulting in high output due to a reduction in energy loss associated with exhaust and cooling systems, the movement of mechanical parts, and other aspects. As a result, the newly developed 2.0-liter gasoline vehicle and hybrid vehicle engines achieve world-leading thermal efficiencies of 40% and 41% respectively. Said simply, Toyota today has reportedly achieved motors with a 41% thermal efficiency, which is a significant achievement when most gasoline engines have efficiencies of roughly 25 to 33%. The Dynamic Force engines are a family of petrol engine series developed by Toyota under the brand's new global architecture, TNGA strategy. The engines were developed alongside the TNGA family of vehicle platforms as part of a company-wide effort to simplify the vehicles being produced by Toyota. Their Dynamic Force engine strategy is based on improved thermal efficiency. Thermal efficiency is the amount of energy produced when a combustion engine burns fuel in relation to the amount of that energy that is converted into mechanical energy. The bane of the internal combustion engine, ICE, has always been that from a thermodynamic view, the ICE is very inefficient. In addition, compared to existing engines, the new engines achieve increased torque at all engine speeds, from low to high rotations, and will comply with expected future exhaust regulations in each country in advance. Toyota put its focus on making a better engine by improving thermal efficiency, which results in increased torque and increased horsepower. And that focus has earned Toyota some significant notoriety with their Dynamic Force engine strategy. The cars and trucks produced by Toyota are the longest lasting, with an average of over 200,000 miles, according to Mojo Motors. Apparently, the company does not sacrifice quality at any cost. Over the years, its management system has relied on different innovative approaches to ensure the desired result. The company equally sold 10.5 million cars last year, even with the COVID-19 pandemic that affected the whole automobiles industry, production, and output. Each new model includes some form of innovation. The company is focused on continuous improvement. Quality is the cornerstone of its international success. How Toyota does it. Dynamic Force engines are designed to improve the speed of the combustion process and minimize energy losses. The motors possess longer than the typical conventional E-engine stroke and a higher compression ratio for improved thermal efficiency. To achieve improved thermal efficiency, Toyota has modified its engine designs by focusing on how to speed up the combustion process. They achieve this with their modern Dynamic Force engine by optimizing the stroke-to-bore ratio by lengthening the stroke and narrowing the cylinders. Optimizing the airflow tumble into the cylinders by widening the angle between intake and exhaust valves to improve fuel and oxygen mixing for better combustion. Optimize thermal management using variable control cooling systems that support optimized combustion with minimal energy loss as heat. The engine was developed as an engine that is claimed to achieve both driving performance and environmental performance while pursuing high efficiency and low fuel consumption, as well as having a direct feeling, smooth, and pleasant acceleration performance. The angle between the exhaust and the intake valve has been widened, while the intake port shape has been changed to provide a more direct airflow part to create a tumble flow. A more controlled swirl pattern in the combustion chamber distributes the air-fuel mixture more evenly ahead of the compression phase, and this adds power and efficiency. Specifically, the cylinder head and intake port design improve the tumble flow to increase the air intake volume. The majority of intake flow is across that portion of the valve closest to the cylinder centerline. Other methods include expansion of the valve clamping angle. The angle between the intake and exhaust valve centerline is 41 degrees. The previous design was 31 degrees. Application of updated D4S multi-hole injector system to achieve high-speed combustion, resulting in thermal efficiency of over 40%. Cylinder centerline is offset from crankshaft centerline, meaning that piston top dead center is always equivalent to several degrees of crankshaft rotation. In the development and production of the engine, Toyota claims it would be a completely new engine design based on the TNGA strategy. Previously, Toyota offered about 800 engine variants, most of which would be replaced with a much simpler lineup of 17 versions of 9 dynamic force engines. Toyota is also simplifying its lineup of transmissions, hybrid systems, and all-wheel drive systems, starting with the 4-cylinder 825A type installed in the XV70 series Camry in June 2017. The V6 V35A and 4-cylinder M20A types had also appeared. On 16 October 2019, the 3-cylinder M15A type, which would be installed in the XP210 series Yaris, specifically designed for Japan, Europe, Australia, and New Zealand, was officially announced. On 12 June 2021, the first turbocharged 4-cylinder model, named T24A, was introduced by the AZ20 series Lexus NX. The dynamic force engines introduced an updated nomenclature system for Toyota engines and no longer employed the traditional iteration or generation of the engine followed by the 1-letter or 2-letter designation for the engine family, such as 5M GE or 4GR FE, being from the M and GR engine families respectively, and instead incorporate the engine's displacement in between a 2-letter code, such as the M20A, with a 20 denoting a 2.0-liter engine. To optimize combustion, a combined fuel injection system, D4S, is employed. It uses both direct and port injection and controls fuel injectors for the best performance, fuel economy, and lowest emissions depending on the engine load. In light to medium load engine ranges, both direct and port injectors are used together to provide an optimal air-fuel mixture for lower fuel consumption. When the engine is under heavier loads, only the direct injection is used to improve fuel-air charging efficiency, help avoid engine knock, and increases its output. What do you think about the latest Toyota Dynamic Force engines? Let us know by leaving a comment in the comments section below. Thanks.